some of them are big complicated buildings like this one, like big lab buildings that we've got, simple office and classroom buildings and residence halls and then, theaters, right? So we've kind of got it all here. It's like a mini city. I've taken a few of Patrick's classes in years past at the Wake Center, so I know the program you guys are going through pretty well. And I think the goal today is we're gonna stick to kind of the east side of campus and do a big loop and check out some of our more interesting lab science and engineering buildings, and then we'll walk by one of the buildings that's under construction right now. So we're gonna probably go in one building. So those of you guys who have a mask, we can do that. Those of you who don't, unfortunately, you got to wait outside. But whatever, we'll keep it quick. And we are going to be focusing. I'll try to talk kind of about construction and the lead process and that. But like I said, my focus is kind of on operations and energy efficiency. So I may talk more about the kind of the energy and resource conservation focused stuff. And Patrick can fill in the gaps. But we're going to see some cool stuff. We're going to go up on the roof, get a nice view, look at some mechanical equipment, talk about what everything does, and some of the things that we do to be more efficient, save energy, save money. It's an expensive campus to run. Our power bill is anywhere from $500,000 to $1 million a month, depending on what the season is, right? So in the summer, when it's hot and when rates are high, we're paying those time of use rates. We'll hit seven figures on our monthly. Wow, that's just power.
So I've noticed over the years, and I just see it right here.
Yeah,
you've got solar on pretty much every parking structure and other places.
Yeah.
What percentage does that offset much?
Yeah, that's a good question. So
would the bill be even that much higher if you didn't have?
So these definitely save money. We've got we put up 12 of these big solar systems between 2016 and 2020 under a power purchase agreement, where we basically say, all right, solar company, come in, build the system for us. You own it, you operate it, just sell us the power. And every unit of energy we buy from that, we don't buy from Edison. And so if the time lines up correctly, if we're in like peak pricing time with SoCal Edison, and we can buy a kilowatt hour of electricity from one of these sites, we're not buying from Edison, we can save a lot of money.
At a lower rate.
Because this rate is locked in. So we said, that's what it's all about. Negotiate the rate. Flat rate, doesn't matter time of day, time of year, and that stays flat
forever,
for 20 years.
20 years, yeah.
So
wow.
As Edison's rate gets more expensive, these rates stay the same and the savings grow.
Have you ever, and you may talk about this, so just shut me up getting ahead of it, but have you guys ever considered wind?
It's been considered.
Because there is a fair amount of wind.
Yeah, it has. And I'll show you the site that it was considered for.
Yeah, you showed
up. We'll
up.
talk a little bit about that when we get over there.
Yeah.
All right, he's here. We were waiting for you.
Hey, Tyler, great.
It took me a little longer than expected to get here on my bike.
Yeah.
Could take less.
It would have been slower.
And how'd you find us?
It would have been
slower?
How'd you find us?
I walked really far.
They have a bike rack over there.
Yeah.
Hi there.
And I figured you might call me, so I've been waiting for your call.
Oh, yeah.
It's great that you got here. Thanks.
So in terms, so you asked what amount of power usage did these solar systems offset? There's one power meter for the whole campus, so it comes in at 66,000 volts. We have a substation on the other side of the campus where it goes from 66,000 down to 12,000 volts through big transformers, and then it's distributed around campus at 12,000 volts via a system that we own. So big loop circuits that go to every building on campus, and so we pay that one meter, is that one $1 million+ bill some months, and on a really hot day, say in September, everyone's here, we're really cranking, we're probably using about 15 megawatts at our peak, so 15 million watts of power instantaneously. These sites do about 6.5 megawatts when they're all cranking. That's their rated capacity. So we never really get that much out of them, but maybe 4.5, 5 megawatts. We'll shave that 15 megawatts down to say 10, right? So we'll come up in the morning, boom, the solar will hit, we'll avoid that peak, and then we'll drop back down at night. Over the course of the year, though, it's really only about 15% of our total usage is coming from these solar systems, and the other 85% is coming from Edison.
So that's a great fact to know. That when you drive around, you just see solar everywhere, and it's an illusion that we're winning the game because there's so much solar, because it's 15%.
Yeah.
And everywhere it's that way. That's why I keep telling the class, we need to just pepper this place. Every flat roof in town needs solar to make this work.
Totally.
And it looks like a lot's happened. You guys, in that
Yeah.
5-year period.
These are big arrays, and you know, this is one of the newest ones. So you see, it's got a bunch of structural steel. It's
Yeah.
beefy. You see all the big inverters. This is about 800 kilowatts on this garage. When we go up to the roof of Brenham Hall, you'll see the very first solar system that was ever put in on campus around 2002. It's about 50 kilowatts, so a whole heck of a lot smaller. And
Yeah.
we just weren't really doing it right back then, and you'll see what I mean when we get over there.
There's John. Okay.
Is John the last guy? When,
Yeah.
when John gets here, let's start
John's
walking.
the
We'll
last
go
guy.
down to Brent.
Okay.
Are we going to use the mic?
What's that?
Are we going to use the microphone for this?
Oh. Well, you're probably picking it up.
Maybe like the factor we would use for something like this is a whole lot more expensive per kilowatt than like your rooftop solar would be. Just look at all the steel, right?
A lot of steel.
So maybe your rooftop system is something like $2 a watt, $2,000 a kilowatt. So if this is 800 kilowatts times 2,000, what's that?
16,000? No.
1.6 million. It's several $1 million for sure.
Gotcha.
Overall, the 6 something megawatts that we put in probably would have been about a $25 million project, but we didn't pay for it.
But yeah, you said you have,
That's one of the benefits is like,
evolution,
all right, let's walk. We're gonna go down the bluff. We're gonna go to Brent Hall as our first stop.
Well, it's so great to have you guide us because you've got a great knowledge of this place.
No worries. I've been here a while.
Yeah, I know.
Been here 13 years now.
Well, you must be a pretty important part of this because this system is big and complex. They've got to keep working.
To some degree, like the business terms were the most like kind of complicated to get through on these solar projects because we don't maintain them, and that's a huge benefit to those things, right? We don't have to touch them.
Right.
I guarantee if we did, you know, those things would be, every time an inverter broke, we'd probably be waiting 2 years for something to happen because it's nobody's first priority.
Well, I talked to them about leasing, as a foolproof backup because there's no reason you can't have solar now. I mean,
Yeah.
you have the room for it.
Yeah.
And so that's really been great for people who can't come up with the money up front. But I never thought about commercially.
Yeah.
How valuable that is. It's great.
Another thing like that makes it a benefit to the campus is we don't. The UC is federally tax exempt, technically a nonprofit, right?
Yeah.
So we wouldn't be able to get the 30% federal tax credit for a big solar system like that. But if we don't own it, a big solar company comes in, they can find people who can take that tax benefit and invest in the system and just get their steady payments.
I hadn't snowboarded in years, and I went snowboarding 2 weeks ago.
You must know Julie Hendricks.
Yeah.
She works here now.
Yeah, I know. Well, she's pushing the Munger thing, isn't she?
Kinda, but kinda not. I think she's kind of on the
She's in a
sidelines.
position where she probably has to.
Yeah, I mean, I don't know. She's the campus architect, right?
Yeah.
So,
Yeah.
a lot of people are getting steamrolled by this Munger project. That's all I'll say.
Yeah. Well, the other thing is that the distance away from actually getting housing.
I heard that.
That's
I heard
another.
They loved it.
That's probably one of the more legitimate complaints.
Yeah. Let's talk about this building for a second. So I want to stop real quick. I want to talk about this building, Harold Frank Hall. This is our Engineering 1. So this building is built in the mid 60s, and kind of different take on maybe what you'd build right on the coastal bluffs here versus what we would do nowadays, right? Which is what we're going to see with something modern. One thing that always has struck me about this building, like, it doesn't really have a whole lot of deference for this, right? Kind of, so you got some little windows on this side, and it might as well be a building anywhere. And in fact, it was a building that was built on the Yale campus. There's an identical building, and basically the university, UCSB, took the blueprints for that building, built the same thing right here in the very early days of the campus, right?
Where was it from?
Yale.
Yale. Right?
Yeah. So you go in here, I mean, originally there was like mud rooms and stuff that like you wouldn't have in California in this building. So this is kind of an example of like some of the early development on campus and the approach that it took. And we're going to walk down to more modern buildings and see just how different the campus is doing things now.
So let me say something here. So we've been talking about controlling solar gain in the houses. We didn't talk a lot about outside things. We did say there were overhangs and stuff, but look at this building over here. There's wooden overhangs. It's a cement,
Trellis.
Yeah, cement or block building, and they've got these overhangs with these trellises with plants on them. It's kind of an interesting combination.
Yep.
I don't happen to like it, but I think I mean the looks of it, but I think it's effective.
Yeah.
And then this one here, you'll see a lot of this on campus. The front of this building, which is I guess more south.
Yeah.
You get those concrete shading sections. We call it brise soleil in architecture, and it, in a way, they're like overhangs.
Yeah.
But they're more geometric. That was the style back when this building was.
Those eyebrows are a really common feature in some of the older buildings on campus.
Yeah.
And like, so back to this building, you see that nice office there with the round windows. That is one of the, you walk in that room, it's always 85 degrees in there. The AC can't keep up. There's no shading. They're letting in all that direct solar penetration. Doesn't matter on the time of day. Sun comes up over there, sets over there. It's always getting direct sunlight, and it's always super hot.
So what kind of walls do they have? Masonry walls or any kind of?
Yeah, I mean, it's all insulated, but I mean, the goal.
There's not enough thermal mass to absorb that heat. That's
Exactly. So the goal is to let the light in, but not let the sunlight penetrate directly. You want the light so you don't have to rely on artificial lights, but you don't want direct sunlight in because, you know, it's going to come in as sunlight and it's going to hit whatever's in that room and it's going to re-radiate as heat. So that's a big problem for spaces like that.
Yeah. And then they just go over it with air conditioning, so it doesn't really matter. But then you're adding energy on top of that. You know? Why?
So let's go to Brent. We're going to go up on the roof over there.
That new building next to the library.
That's the classroom building.
Oh yeah.
Do you guys have any desire to walk by that?
Oh yeah.
Okay.
Yeah, we'll go wherever you want to go.
Okay. I need to peel off at about 3:15, so I think we all have plenty of time.
Oh yeah.
General parts, we do it every day.
I really appreciate you doing it.
Yeah.
It's hard to find things around town because, you know, it's a residential construction program, so I'd like to do more residential stuff, but
Let's head this way.
you know, it's private.
Yeah, what are you gonna do,
private
right?
owners.
I know.
You can't find them. They don't want a whole class to track through.
Yep.
So I end up doing a lot more commercial. But you know, it's all relevant.
25, 50. We did a there and back to the summer one.
We usually go to Dennis Allen's house.
Oh, the Victoria Garden.
Yeah.
Yeah. I went to that one when it was being built. That's a really cool one.
Yeah.
He's
But,
probably
you know,
had thousands of people come through there.
He's fine.
Yeah.
Also he did it was built by this woman in Washington, I forget her name, a prefab place, and he was the contractor that put it together down here, and it was on Pedregosa in the Mission District.
Okay.
We used to go there for years, but you know, the owners would switch, and I always felt guilty about going there. But
Yeah.
No, it's fine. We're walking towards it.
So we'll stop here for a minute. So so this is Bren Hall. Yeah, exactly. This building is Bren Hall. This was built in 2001. It opened up, and at that time, it was the first LEED certified building in the UC system. So I'm sure you all have talked about LEED certification. The kind of the interesting, well, the challenging thing is this is a lab building as well as it's got a bunch of offices. So this wing right here is all labs on the first and second floor, and then we've got classrooms and offices on the third and fourth floor, and then this wing here is all offices, classrooms on the first floor. So when you see these offices on 2, 3, and 4, those are not air conditioned. Those are all naturally ventilated, and so the idea is you've got your window facing the ocean. You've got a little, they